Welcome to Astronomy Daily, your daily dive into the latest space and astronomy news. I'm your host, Anna, and I'm excited to take you through some fascinating updates today. We've got riveting stories lined up for you, from China's ambitious satellite constellation launch to rival Starlink to a groundbreaking revelation by the James Webb Space Telescope that has astronomers buzzing. Plus, we'll delve into NASA's quirky but educational screaming balloon demonstration involving pennies in space. It's going to be an enlightening and fun-filled journey through the cosmos, so let's get started. A Chinese state-owned enterprise has made a bold move in the realm of space technology by launching the first batch of satellites designed to rival SpaceX's Starlink. This ambitious initiative marks a pivotal step in Beijing's broader strategic objective of developing a robust broadband network to compete on a global scale, not only in commercial domains, but with significant military implications as well. The launch, which took place at the Taiyuan Satellite Launch Center in Shanxi Province, was spearheaded by Shanghai Spacecom Satellite Technology, or SSST. This is a major milestone in SSST's Thousand Sails Constellation project, also known as the G60 Starlink plan. Initiated last year, the plan aims to deploy over 15,000 low Earth orbit LEO satellites by the end of this decade. LEO satellites typically operate between 300 kilometers and 2,000 kilometers from the Earth's surface. Their lower altitude allows for cheaper deployment and more efficient data transmission compared to satellites placed in higher orbits. The first batch of satellites launched is just the beginning, with plans to deploy 108 satellites this year alone and 648 by the end of 2025. The ultimate goal is to achieve global network coverage by 2027 and fully deploy the 15,000 satellites before 2030. This ambitious plan is part of a broader trend where various countries are competing to occupy Earth's lower orbits, with significant ramifications for global communications and military capabilities. Starlink, the brainchild of Elon Musk's SpaceX, has already become a significant player in this field, boasting around 5,500 satellites in orbit and serving tens of thousands of users in the United States. The comparison between Starlink and the Thousand Sails constellation is inevitable, as both aim to provide near-global internet coverage, but the competition goes beyond commercial interests. Chinese researchers within the People's Liberation Army have been studying Starlink's deployments closely, particularly its role in the Ukraine conflict. Their concern is not unfounded. The potential military applications of a vast satellite constellation could indeed influence the balance of power in any future conflicts. An op-ed published in a leading PLA mouthpiece earlier this year described Starlink's deployment as a serious threat to the security of space assets of various countries, highlighting the anxieties about how such technology could be used against China in a military context. The strategic importance of developing a competing mega constellation cannot be overstated. If successful, the Thousand Sails constellation would provide China with a similar level of connectivity and control over space-based communications, thereby reducing reliance on infrastructure operated by potential rival states. The significant investment and rapid deployment timeline underscore the urgency Beijing feels in closing the gap with SpaceX's Starlink and ensuring future technological and military parity. SST's achievement is receiving significant attention both domestically and internationally. While the company has not commented on this latest development, it's clear that the launch represents a promising start. As the initiative progresses, it will be crucial to monitor both the technological advancements and policy implications resulting from this rapidly growing network. The James Webb Space Telescope's Mid-Infrared Instrument, or MIRI, has delivered a truly breathtaking discovery. What astronomers long believed to be a single star, known as WL20S, is actually a twin star system. This revelation doesn't just add a fascinating twist to our understanding of this celestial body, it opens up new avenues in the study of stellar life cycles and planetary formation. So how did this all come to light? The story begins with astronomers turning NASA's James Webb Space Telescope toward a group of young stars called WL20. Located in a star-forming region of the Milky Way called Rho Ophiuchi, this group of stars has been the topic of scientific scrutiny since the 1970s. Despite being studied by at least 5 different telescopes over the years, it was Webb's unprecedented resolution and specialized instruments that revealed WL20S to be 2 stars rather than 1. The discovery was unveiled at the 244th meeting of the American Astronomical Society. Using MIRI, scientists discovered that these twin stars also possess matching jets of gas streaming from their north and south poles. Imagine their excitement. After decades of studying what they thought was a single star, they suddenly found themselves looking at not one, but two stars with intriguing features. Mary Barsany, the lead author of the new paper presenting these results, put it aptly, "Our jaws dropped." Adding another layer to the mystery, further observations by the Atacama Large Millimeter Submillimeter Array, ALMA, provided even more surprising findings. ALMA, with its array of over 60 radio antennas in Chile, detected disks of gas and dust encircling both stars. Given the star's age, it is highly probable that planets are forming within these disks. This means we're not just looking at a new twin star system, but potentially at a burgeoning planetary system as well. But why hadn't we seen this before? It turns out that WL20 is hidden behind thick clouds of gas and dust, making it difficult for visible light telescopes to penetrate. Webb, however, detects in the infrared spectrum, which can pass through these obscuring layers. MIRI, specifically designed for such observations, can detect the longest infrared wavelengths of any instruments on Webb, making it especially suited for looking into regions like WL20. This high-powered observation means that we can now see not just the structure of these twin stars, but also their behavior. The jets of gas detected by MIRI are composed of ions, atoms stripped of some electrons, which radiate at mid-infrared wavelengths. These features would not be visible at the sub-millimeter wavelengths observed by a facility like ALMA, thus highlighting the importance of having both types of telescopes working in conjunction. They say a penny doesn't go far these days, but NASA has added its own twist to that phrase by sending 2 pennies into space. These pennies, believe it or not, are on an extraordinary mission aboard the International Space Station, traveling millions of miles and proving that even the smallest objects can play a big role in education. On August 4th, 2 humble US 1-cent coins lifted off for the ISS aboard the SS Francis R. Dick Scobie, Northrop Grumman's 21st Cygnus cargo spacecraft. Named in memory of the Challenger shuttle commander, these pennies were part of an uncrewed capsule's 8,200 pounds of cargo, launched from Cape Canaveral Space Force Station in Florida by a SpaceX Falcon 9 rocket. What's the mission for these tiny travelers? They're part of NASA's latest STEAmonstration, an educational project designed to engage grade school children in science, technology, engineering, and mathematics. Michelle Hooks, Education Project Manager for NASA's Office of STEM Engagement, explained that the pennies are crucial to an experiment called the Screaming Balloon Demonstration. In this activity, 1 penny is inserted into a deflated balloon, which is then inflated and given a spin by an astronaut. The experiment will compare the motion of the penny to a hex nut spun inside a second balloon. What makes this all the more fascinating is the accessibility of the materials. Pennies are abundant and familiar to students, making it easy for them to replicate the experiment in their classrooms. This hands-on approach brings the excitement of space right down to Earth, allowing students to draw direct connections between their everyday lives and the extraordinary work happening on the ISS. But it wasn't an easy task to find the right pennies for this mission. NASA wanted pennies minted in 2024 to mark the year they were sent into space, and they needed to be shiny, camera-ready coins. Hooks, along with her team, went on a penny hunt that spanned local banks and personal spare change. After checking hundreds of coins and enlisting help from bank tellers, NASA staff, and local educators, they finally collected a pair of perfect 2024 pennies. These aren't the first pennies to venture into space, though. Previous missions have seen pennies flown on Apollo missions and even to Mars. For instance, a penny flew aboard Apollo 11 with Neil Armstrong, and multiple coins traveled on Apollo 14 and 15 missions. A particularly valuable penny, a 1793 flowing hair cent, even hitched a ride on Gemini 7, later selling for over $82,000 at auction. Today, NASA has strict policies against astronauts personally flying items like coins to prevent exploitation. However, uncrewed missions like the current Penny Project allow a modern continuation of this tradition. And these pennies aren't just about looking good, they help carry forward NASA's long-standing educational goals. The coins are set to be reused in various ways aboard the ISS. maximizing their educational impact before they eventually return to Earth. That's it for today's episode of Astronomy Daily. I'm Anna, and it's been a pleasure to share these stories with you. Don't forget to visit our website at astronomydaily.io for all the latest news, listen to past episodes, and sign up for our newsletter. You can also find us on social media. Just search for Astro Daily Pod on Facebook, X, YouTube, and TikTok. See you next time.